All right, hey guys. This is the review we did the day before the test, but I wanted to use this. I'm going to go through them kind of quickly, but I think what's really important here, what you should get out of this, is I'm going to show you how to use Desmos and a TI-84 to kind of help you navigate some of these problems. You still have to show all your work, you still have to show your formula, your Z and P value, but I do want to show you where Desmos can start to help you out. And you can really use Desmos multiple choice. You can use it to check your work as well. This is going to be that hypothesis test review we did the day before the exam. I'm going to go kind of in backwards order because we should be starting with our hypotheses and defining our parameter. So what we have here is a people are concerned that new tougher standards and high stakes tests adopted in many states may drive up the high school dropout rate. The National Center for Education Statistics reports that the high school dropout rate was 10.9%. One school district, whose dropout rate has been very close to national average, reports that 210 out of the 1,782 students dropped out last year. And then you'll see the question is there experience evidence that the dropout rate may be increasing? 5% level of significance. So let's start, and this is hypotheses. This is your choose. So we need to do the whole thing. Our procedure, we're looking at a one sample Z test for P, and P is representing the true proportion of high school dropouts. Now, a couple things we need to have here. Let's talk about our null and our alternative. Our null is that the true rate is that 10.9%. Our alternative, if we go back and look, we're being asked, is the rate increasing? So we want to know, are we seeing more than 10.9%? Now, again, I always talk about we can look at our evidence based on our statistic here. So we have our p hat 210 divided by 1,782. This is 0.118. That's greater than 1 or 0.109, telling us, hey, at this 5% statistic level, we don't know yet, but we do have some evidence to support that alternative hypothesis. Now, before we can go through and actually check that, we need to check our conditions. This is your check step. Was it random? In the problem, we don't necessarily know. So it could be an issue. What we're going to say is that the school was chosen at random. And we care about that because we can now generalize to the population. For our second one, our 10% check, 1,782 is definitely less than 10% of all high school students. Now, here we care because we can sample without replacement. For three, our large counts. So let's check. 1,782 times our null hypothesis. That is 210. That's greater than 10. We can also check those failures. Now, remember, we do need to check both sides of this. And we do need to actually write out how I'm doing it now, where we show that, yes, indeed, they are both greater than 10. And why we care. We care about this because we want to know, is the sampling distribution going to be approximately normal? Here, because we pass large counts, it is going to be approximately normal. Okay, those are things we've done for a while now. Now let's talk about 3. The formula Z and p-value. This is our calculate step. Now, what I'm going to tell you, you still need to write Z because it's Z. You still need to write out your formula. I would even still say go as far as fill this in. Remembering that P is just your null hypothesis. And now you can do a couple things here. You could just go through and calculate this by hand and get your p-value. Or what we're going to do is we're going to go to Desmos. We're going to click the plus. We're going to click inference. And we're going to click this one that says Z test for proportions. What we have to type in is our successes, the 210, and our sample size, the 1,782. We're going to hit create test. What you will notice is not only does this give us now this Z prop test, it's going to give us a confidence interval if we cared about that, which is actually kind of interesting because you could go through and say, based on 95% confidence interval, are you going to reject or fail to reject based on what we see within our interval is an interesting one. But today we care about the significance test. Now, here's what you have to do. You have to type in your null hypothesis. You also have to know, am I looking for the left tail, the right tail, or both? This is based on if you are greater than, less than, or not equal to for your alternative. We are greater than, so we're looking for the right tail. What you will see here is we're given 2 things, that our Z is 1.198 and our p-value is 0.115. Now, we can say here that's approximately 1.198. This actual calculation is about 1.22. Either way is going to be fine. AP takes anything rounded within reason. They would take the rounding of 210 over 1,782. They would take that as 1.118. So you'd be fine either way. If you follow along with the key and your calculations with the calculator, this is 1.22. Now, the reason why I'm getting 1.22 is because I rounded. If you use Desmos, like you saw here, you're going to get 1.198. Either way is fine. Here, if you follow and do this through table A with 1.22, you're going to find that your p-value is 0.11. If you go through Desmos, your probability of Z being greater than 1.198, as we saw earlier, is the 0.115. What you will notice here is both the Z and the P's are very similar. It's just a rounding issue of which way did you round, how did you round, when did you round in the problem. As long as you are within a set range, either of these are acceptable answers. Now, I'm going to rock on with the Desmos answer here. So we're going to do our conclusion. Because 0.115 is greater than our alpha value of 0.05, we fail to reject our null, and we do not have convincing evidence that the high school dropout rate is increasing. Okay, so I'm going to go through. I am going to quickly go through the hypotheses for the second two questions. I'm not going to do the checks. The checks do pass. You need to do them. But I'm going to do the hypotheses and the formula and show you how to use this on Desmos. So for B, according to the Center of Disease Control and Prevention website, 50% of high school students have never smoked a cigarette. Then we see Taylor wonders whether this national result holds true. And then for his class project, he surveys a simple random sample of 150 students. 90 say they've never smoked. Now, this one's a little interesting here. It's still a one sample Z test for P. So we're still going to do a one sample Z test for P. Key in this one, though, is the true proportion of students, and we should specifically say high school students, that have never smoked. What we'll see here, our alternative is that it's 50%. Or sorry, our null is that it's 50%. Our alternative is that it's not 50%. We still have that significance level of 0.05 and a p hat of 90 over 150, which is 0.6. So we do have some evidence. Note when it's not, when we have this not equal to, we're going to see a two-sided test here. I'm going to leave it up to you to do these conditions. Because it's still a one sample, it's still Z equals p hat minus p over the square root of p times 1 minus p over n. And we still have 0.6 minus our assumed null value. And then times 0.5 times 0.5 over 150. Now I'm going to go to Desmos for this. Okay. Do inference, Z test for proportions. We have 90 people out of 150. Significance test, our null hypothesis, it's going to default to 0.5. I like to put 0.5 just in case. And like we talked about, because this is not 0.5, our alternative says that P is not 0.5. It's a two-sided test. Now, what I want you to notice here is that if let's say I incorrectly, or I just saw, because Desmos gives me the same one here. If you calculate this out, it is 2.449. If I just did the right side, what you'll notice is that my p-value is 0.007. Using our statistical knowledge with approximately normal distributions, we should come to the conclusion that if we check the left side as well as the right side, we would still be looking at the same z-score, just on the negative side, leading that our p-value is just double our single side. Our p-value here is 0.014. So the probability here, and we would do 2 times the probability of z being greater than 2.449, 0.014. That's our p-value. This is the p-value. And now we make that conclusion because our p-value is less than our alpha value. We will reject the null, and we do have convincing evidence that the true proportion of high school students who have never smoked is not 50%. Sorry for the bad handwriting there. Just want to make it quick for us. Okay, so that's how Desmos handles two-sided. So we've seen a one proportion z-test for a single side and for a two-sided test. What about if we have a difference of proportions? I can hear you asking that. Okay, here's what's cool about this. So high levels of cholesterol in blood are associated with higher risks of heart attacks. Will using a drug to lower blood cholesterol reduce heart attacks? So now we have a Helsinki heart study recruited middle-aged men with high cholesterol but no history of other serious medical problems to investigate this question. We do see that the volunteer subjects were assigned at random. So just a side note, because I'm not going to do the conditions again. The volunteers are randomly assigned. So yes, they are volunteers, but within this group, they are randomly assigned, which gets us around the random check. So we're still random. We can still generalize the population. What you'll notice, and check the key, because of random assignment, we don't care about sampling without replacement. So you don't have to check the 10% condition. What I always say is put 10%. Random assignment means we are sampling without replacement because we're not actually doing anything other than random assignment. So just so you know, but you can check the key for that. We have two treatments though. We have 2,051 men taking a drug to reduce their cholesterol and a control group taking a placebo. We see that 56% of the men for the drug and 84 of the men had heart attacks. And then we're seeing here, do the results of this study give convincing evidence that the drug is effective? With the drug being effective, so one thing you want to do here, P1 is the true heart attack rate for the drug. And P2 is the true heart attack rate for the placebo. Okay, what that means though, when we're saying, is it effective? What that means is, are we reducing the heart attack rate? In other words, we want P1 to be less than P2. What this ends us up with when we're dealing with the difference is that P1 minus P2 equals 0. Or sorry, scratch that. That's for your alternative. Got ahead of myself. We know that the null is always that they're the same. Sorry, my bad there. Not going to restart all of this for that. That was our alternative. Our alternative is saying that we want P1 to be less than P2, meaning P1 minus P2 should result in less than 0. Couple things to note here. Don't forget, you still have an alpha value. Also, don't forget, you need to not only know what P1 and P2 hat are, you need to do the P combined in order to do your formula. P combined, I will help you out with here, is this fraction. And it gives us a proportion of 0.0343. That is the value you will use for your large counts and for your formula. Again, you check the conditions. I'm here to provide you with your formula. So P1 hat minus P2 hat minus P1 minus P2 over our formula here of PC hat times 1 minus PC hat over N1 plus PC hat times 1 minus PC hat over N2. We plug all of this good stuff in, And again, this is why you have to calculate your um, statistics. We do all of this though. And one thing as I'm writing this out for you, because I don't think you need me to just read it off, it is extremely important here that you still write all of your stuff out. Um, I always say you want to use Desmos to ensure that you are getting the correct answer. You don't want to use Desmos as the crutch of the correct answer. You want to use it to get the correct answer after you've already done all your work. It's just a tool to check yourself, right? It earns you no credit to just simply say z equals blank from Desmos. No one knows what you mean by that. Show the formula, show what you plugged in. Then you can type this in the calculator and go, all right, guys, now I'm going to check. So here, z test, we can do difference. 56 is the first success over 2051. And then we just simply do sample 2 and 84 over 2030. Now make sure sample 1, sample 2, P1, P2, you got to put them in the correct order, right? Create our test, significance test. Our null is that there is no difference. And we're looking to the left, right? So to the left here, we're going to get a z-score of negative 2.47, which means our p-value, the probability of z being less than negative 2.47, coming from Desmos, 0.007. All right, and now what's our conclusion? Because 0.007 is less than 0.01, we reject the null, and we do have convincing evidence of a lower heart attack rate for middle aged men who take this gym fibrosol than for those who take only a placebo. Cool. So that's how you do it with Desmos. I think Desmos is a great tool. You can see everything. It's nice. It's really user friendly. For those of you that are more a TI-84 fan, under stat, if you go to tests, you have to scroll down and it's going to be a 1 proportion z test or a 2 proportion z test. 1 if it's something like number 1 or 2, and I'll just show you number 2 so you can see that you can do a two-sided. For number 2, our null was 0.5. Our successes were 90 and our trials were 150. Then you would do not equal to. You can color it because you can have it drawn. I just want to calculate. And then it will give you all of your information here. Let's see if I can, yeah, there we go. So you can see here your z-score, your p-value, everything there that you would need. They should all be the same. And then the only difference is if you were to use a 2 proportion, is that you have N1, X1, X2, N2, and then P is not equal to P2, P1 is less than P2, and greater than. So I can show you just real quick here what we just saw on number 3. So 56 over 2051, and then 84 over 2030. We said that P1 has to be less than P2. We're going to calculate it. And you can see here, with P1 being less than P2, z-score of negative 2.47. Our p-value, Desmos is going to round. TI-84 is going to give us more decimals, 0.0067, 0.007. They work the same. So you get the same thing there. So with all that said, I hope this is helpful in just using Desmos here, like some tools. Yes, you still have to write all of this to earn full credit, but you can use this to check yourself. You can use it for multiple choice, or maybe you just don't want to type all of that in. That's cool. I think it's easier to type in a couple numbers than all these numbers. So with that said, I hope this helps.